All right, so everyone can go ahead and log into Canvas. We're going to continue on with the Linux side of things that we've been working on, or that we worked on a couple of weeks ago. And so I think we made it through kind of the first section of kind of the custom NetLabs pod going over some basics with Linux. We're going to move on to the second part, which is going to touch base on some of the things Dr. Brown was going over with the SoCal Cyber Cup team in terms of SSH, public and private key stuff. And so we're going to continue on and kind of learn how to move from one system in a Linux environment to another system that's on the same network using SSH transfer files and things like that. So let me start sharing here, show you all where we'll be. All right. All right, so in Canvas, we're still going to be working on the week two Introduction to Linux module. And so the PDF will also be in NetLabs here, but if you want to pull it up and follow along, it's this competition training week two PDF. And we made it about halfway through last time. And so we're just going to be continuing on where we left off last. So in the meantime, everyone can go ahead and click on the NetLab Plus link under workshop information. And again, this will take you to our custom NetLab virtual labs that we're going to use as we walk through and learn this material. So we'll be able to practice hands-on. And you'll all be making the same reservation that you did a couple of weeks ago, which is just for the Linux content. So when you log into NetLab for the first time, you'll click New Lab Reservation, Schedule a Lab for myself, and then you'll see a list of available labs. And we're right back into week two, Intro to Linux here. So you'll click on that, and then there will be a bunch of available pods to make a reservation. So just like with all of your classes, you can click this arrow to the right to kind of move down. We have plenty available. And so pick one that's available, click on the red line to indicate you want to start now, and then just change your end time. Probably 7:30 would be fine. You can hit submit, and then once you get back to your dashboard, you'll see one. I see multiple because I have administrator access, but you'll see only one with your name. You can click Enter Lab, and then that'll get you right where you need to be to follow along with what we're covering today. And so I'm going to work pretty much just in this window here as this lab starts up. Under Content, once you're inside of your lab, if you click on the Content tab, these are just the same slides that are in Canvas. So you can follow along kind of in either place that you want to, but these are the same things that are posted in Canvas. And what I'm going to do is I'm going to find where we left off last time. Okay, and so we left off essentially on page 13, it looks like, of the slides here. And so I'm going to pick up from here as the lab loads. We're going to talk through some of the concepts that we're going to practice, and then same format as last week, we're going to learn about these different tools, and then we have some challenges, so we'll jump into our virtual machine that should still be booting up here, and then practice hands-on keyboard, how to interact with these different tools that we learn about. So the first thing we're going to talk about is SSH, or the secure shell. And so Dr. Brown covered this kind of indirectly last time as he was teaching you all about creating public and private keys for authentication with SSH. We're going to take it a step back and just talk about what SSH is and why it's important and kind of what purpose it serves in IT. So SSH stands for Secured Shell, and all it is it's an encrypted protocol allowing secure remote communication most of the time with Linux servers is where you most commonly find it. Although SSH works on Windows, on Mac OS, a bunch of different other operating systems, most commonly you will find it used on Linux in order to, again, remotely access a system. So remote access could mean that I'm on my home computer and I want to access a computer system, across the world or across the country. Over this secure encrypted channel in order to run commands on that computer that's not in my same network. SSH can also be used within a network, though. Let's say I'm on my desktop right now, and let's say I have a server in my garage running Linux, right? And I don't want to have to get up and walk out to that server physically to sit in front of it and type commands. I want to stay on my desktop, but I want the ability to run commands or interact with that computer in my garage. I can use SSH in order to connect from where I am right now to that system, and it's essentially the same as if I were sitting in front of the system. The key takeaway for SSH is that all of the traffic is encrypted to prevent eavesdropping on the network. Before SSH existed, there was a really popular protocol that still exists called Telnet, which essentially did the same thing. Telnet allowed for remote access to servers, and you were given a command line where you could then run commands over Telnet. The big problem with Telnet is there is no encryption. It's the equivalent of HTTP on the internet, which used to be common back in the day, versus HTTPS, or the secure version, which is encrypted, which is what almost all websites use nowadays. And so Telnet had huge issues because if I was sitting here and I was reaching out across the world to a server in Dubai or something over Telnet to interact with it, think about how many different routers and endpoints my network traffic is going from California to Dubai, probably hitting dozens, hundreds, maybe thousands of different routers and switches along the way for that traffic to get there. If any single one of those endpoints or hops in the network were compromised and there were an attacker just sitting there kind of looking at the network traffic, with Telnet, they could see everything that I typed, including my username and my password and anything else I type on the system. SSH solves that issue. And so really SSH is kind of the modern protocol that should be used whenever possible in place of Telnet today, although you will still see Telnet used on particularly networking equipment still nowadays. Not very many good reasons for that other than on really old networking equipment. Sometimes there's compute resources. It does take a little bit of computing power to do the encryption. And so when we're talking about really old, like 20-year-old Cisco switches or something, some of them might still use Telnet by default due to compute limitations. But any modern networking device you use, if you see Telnet on, turn it off. There's almost never a good reason to be using that. The other thing that I want to talk to you guys about is some flags. So we learned a couple of commands in Linux like cat and ls and like the copy command last time. I kind of showed you all when we did ls specifically that adding -a would show hidden files. When we have a command in Linux, oftentimes almost every command has what we call flags or switches that can be used to add additional kind of parameters to a command or give additional functionality to a Linux command. So we just call these flags or switches, and usually they're in the syntax of
Stop.
a single hyphen or a single dash followed by a letter. And then, each program kind of, the letters have a different meaning, but they all add additional functionality. So in the picture here, like we went over last time, ls on its own will just show output of files and folders in this format. If you add a -l for the long version, it shows the same information, but it gives you a bunch of additional fields, basically. And then like we talked about, -a shows all files, including hidden files and folders. For any of these commands, if you want to know all of the flags available to you, I'm going to jump to my VM really quickly to show this. You can either, if you're kind of stuck on the system, you can always use the man command, which is short for manual. And so if you want to see the instruction manual for any command in Linux, you can type in man and then the name of the command you want to learn about. So if we want to learn about ls, I can type in man ls. And if I hit enter, it's going to pull up this interactive user manual in my terminal. And you'll see one of the first section. These are all of the switches or flags with the characters and then a description of what they do. And so you can kind of go up and down with the up and down arrows on your keyboard to kind of scroll through this file here, see what's interesting or what you want to learn about it. And then when you're done, you can type Q. There's the letter Q on your keyboard to quit, and then you'll have your terminal back. So you can definitely do it that way. If you have a browser, you can also kind of Google for this. So you can just search for like man pages ls, and it should be, the website is man7.org. There's several of them, but this will just show you the same manual pages just in your browser. And so sometimes it's a little easier to search through it if you have access to a web browser where you can kind of look through it. But this is the same content that you'll find in Linux as well. Okay. So man pages are a valuable tool when you're learning a command for a first time. And I should mention too, a lot of commands, you could use them for decades, right? And still never use all the flags. Sometimes there's like dozens, 50 different switches or flags. And most of the time you'll use like 4 or 5 frequently, like in your everyday work. Every once in a while in a CTF challenge, like SoCal Cyber Cup or NCL, they will expect you to use a flag or a switch on one of these commands that's not very common, that won't show up in your day-to-day work, but it's additional functionality. And so always check the man pages. If you're kind of tasked with doing something where you think, well, I should probably use the cat or the grep command to do this, but the way that they're prompting me or phrasing this problem, I don't know what flag I would use with grep to accomplish this. It's not one of the common ones. Definitely kind of look through the man pages to see if they're hinting at something. We're going to talk a little bit about how to create files and directories in the Linux file system. So just some more commands here. Touch will create an empty file. Make dir, mkdir, which is the same command that you would run on Windows, creates an empty folder or a directory. So we'll get into working with those. A couple other commands for interacting with files and folders. So we know how to create a file with touch. We just talked about that. What if we want to delete a file? In Linux, the command to delete a file or a folder is the rm command, which is just short for remove. And this removes files or directories. And I have a note here, use this with caution, especially if you're a Windows user. So if you're a Windows user and you're used to like right-clicking and deleting a file or dragging it to the recycle bin, Windows is kind of much more user-friendly in that if you delete a file on Windows, most of the time you're not permanently deleting it, meaning it goes to your recycle bin, but then you have a recycle bin on your desktop and you can go back and restore the file, right? So you're not really deleting it, you're kind of putting it in a trash bin. And if you really want to delete it, you have to then go and empty your recycle bin. Linux Server does not have this concept. So on Linux Server, if you type in rm and then the name of a file and you hit enter, that file is gone. It's not coming, it's not in a trash can that you can go and restore. It is gone. The only way to get it back is to take one of Professor Barrios's digital forensic classes and use a tool like Autopsy or something to try to go back through and carve out the data there. And even then, you're likely not going to get it back after enough time passes. So just the point of the message is be careful running the rm command on Linux, because if you type in the wrong file name or the wrong folder name and you delete it, for all intents and purposes, it's gone forever and there's no way to recover it. And so just, always kind of be cautious when using that command and double check what you're typing in before you hit enter. Copying files and directories is the cp command, which is short for copy. And the syntax for that is you type in cp, indicating I want to copy, and then you type in the name of the file that you want to copy, and then what you want to call the copy, right? So copy my file, and then my file 2 copies my file to a new file called my file 2, and it's just creating a copy of it. So the contents will be the same, you're just essentially changing the name. And then we have the move command. So the move command does kind of two main things. You can either move a file from one folder to another, move it around the system, but move is also used for renaming files, which it's kind of weird, right? There's not a rename command. It's move that we use to rename a file. And so the way that this works is if we type in mv for move, my file, and then my directory, this will move my file into a directory called my directory if that directory already exists. But if my directory doesn't exist or I make a typo, move will then change its behavior and it will actually just rename my file to my directory. Okay, so that's kind of the key takeaway. When you use the move command, there's two arguments that come after it: the name of the file that you want to move or rename, and then where you want to put it. That second or that last part is what makes the difference on what's going to happen. If the last part of your command is an existing directory, then it will just move the file. It won't change the name. If the last part of the command is a directory that doesn't exist on the computer, then it won't move anything. It'll just rename it. And the file will stay in the same directory, but it'll have a new name now. So that can be, I know, confusing for people who hear about it at first, but just something to be aware of. If your move command isn't working like you thought it did, that's probably why. Okay, next kind of topic we're going to touch on, and this will come in handy here. We already learned about cat to display the context of a file. Oftentimes in Linux, we won't know what type of file a file is if it doesn't have an extension. And an extension is just the name of the file followed by a period and then something like, .pdf. or .docx for a Word document, or .jpg for a JPEG or an image file. Sometimes you will see those in Linux, and in Windows, in fact, these file extensions are kind of hard-coded in, and so they'll always be present. On Linux, they're not mandatory, meaning I could have a JPEG or an image file on Linux that's just named file with no .jpeg. And it's not enforced by Linux that I have to put in a file extension like it is on Windows. So because of that, sometimes you're going to end up with a file and you don't know what it is. Is this a text file? Is it an image file? Is it a PDF file? Is it some type of executable? So instead of running the file or trying to open it to figure that out, there's a command on Linux called file, and it's real simple to use. You just type in file and the name of your file, and this will generally return to you information about what type of file you're looking at. So you can see in this example in the screenshot, it's a little blurry here, but kind of 4 lines down, they type in file and then 1.png. And it does confirm, okay, 1.png, you can see the output says PNG image data. It gives the dimensions and kind of the color scheme of it and other things there too. They do it again with file linux.docx, and it confirms, hey, this is a Microsoft Word document. This is important because, again, these file extensions are arbitrary in Linux. So I could name linux.docx to linux.pdf. It's still a docx file, but if I read it, it'll say PDF. So you could trick a user, right, by naming a file something it's really not. But the file command will always return to you what the file actually is, not what it's labeled, not what the dot says. It actually looks at the binary data, something called the magic bytes, and it determines what type of file it is based on that and returns that information to you. So key takeaway, if there's a file in Linux and you're not sure what it is and you don't want to just open it and run it without knowing, use the file command to get more information about what you're dealing with. Okay, let's see. All right, we'll go through these pretty quickly here because we're going to practice all of these hands-on, and you can refer back to these slides. The next thing we'll talk about on Linux are permissions, and this concept exists in Windows as well. So when you think about permissions on a computer system in general, we're usually talking about who can do what on the system, who can go to certain places on the system, certain directories, who can access certain files on a system. And in Linux, there's kind of two different classes that we put a user in, or we put like, what's the right word for this? There's two different ways that we can define permissions. One is at the user level. So just think the username that you log in as. We can assign permissions directly to a user. The other way is at the group level. And so groups, one or more users can belong to a group. So let's say I have a computer with 10 users on it, and I want 3 of those users to have administrative privileges. On Linux and in Windows, the way that you would do that is you would choose your 3 individual users that you want to be admins, and you would add them on Windows to the administrators group. On Linux, that group name changes based on the distribution you're using, but a common one is adding them to the sudo or sudo group. And sudo stands for super user do. And that is just what administrator is called in Linux, right? On Windows, it's administrator. On Linux, just think, if you hear sudo, think administrator, because it's the same thing. So groups give us a little bit more flexibility, right? If we only could assign permissions to users, I'd have to go to each one of those users and manually like give them administrative permissions. It could take a long time. But since we have groups, instead, I can just define what permissions an administrator should have on one group, and then I can add or remove as many users as I want to that group. And when they're in the group, they inherit those permissions. When you take them out of the group, they lose those permissions. So it just kind of makes permission management a lot easier for a system administrator when you can define it at the group level and then, put people in or take them out of those groups. What we're looking at here with the ls-l to get the long listing, all of these sections on the left-hand side here, and then these first two, have to do with those permissions, those group and user level permissions. And so I will just show we'll use this image here because it explains it well. The first thing you have to know is you see all these different letters, D, R, W, X, R, dash, right? These letters and symbols here. These are specifying what permissions exist for a specific file or folder at the user and group level. So the only letters you really have to memorize for now are the letter R, which gives a read permission. So this means that I can look at a file, but I can't edit a file, and I can't run a file if it's a program. I can read a text file, but I can't change it. The W or the write permission is like the edit permission. So with this permission, I am able to edit a file. I can change the text, I can kind of rename it, stuff like that. And then X is for execute, and this most of the time applies to some type of application file. So whether it's a Python program or on Windows, just an executable file that you would launch, you need the X or the execute privilege to actually run that file in Linux. And so you'll see those different letters. And if the letter shows up, it means you have that permission. And they always go in this order: read, write, execute. And then it repeats read, write, execute. And then it repeats a third time: read, write, execute. A dash in any of those fields means you don't have that permission. So for this example at the bottom right here, this folder, videos, the first kind of I guess I should start. The first letter, D, just stands for the file type. So if it's a directory, you'll see it start with a D. Otherwise, you won't see it with anything. And then it's three groups of three letters that will follow. And so the first group of three, the first RWX, is the user permission. Okay, so the actual user has the ability to read, write, and execute this file, which is basically full permissions. They can do whatever they want with the folder here. The next set of three are the group level permissions. So the user has full access to this videos folder. The group that is also an owner of this folder can't write. They can read or execute, but they can't like change this folder if you're a member of the group. And then the last is like other permissions. And other permissions are basically like if you're not a user listed here or a group listed here, you're an other. So if your name doesn't show up basically under user, owner, and then group, you're in the other category. And we can see that the other permissions are the same. You can read, you can execute, but you can't edit or write. Okay, so user is the first three, the group is the second three, and then everyone else on the system is the last three. And then how do you find out the owner? Like who is the user, who is the group as it relates to these folders? Those are the kind of next two columns here. And a lot of times the user and the group are going to be the same because on Linux, when you create a user account, automatically that user has a group created too that's the same as their username. So that you have a username and a group name, they're the same. We will see, though, in our example that we're going to walk through, how these can be different. So you can have a single user that has ownership over a file or a folder, and then a different group that's not the username that also has ownership. And those permissions are, again, are dictated over here on the left at these different levels. So hopefully this will make more sense and why it's important when we get into our interactive challenge here. But for now, just know that ls-l can give you this information if you're having to figure it out. Most of the time, this will come up too if you're trying to do something with a file and you're getting a permission error. First thing you'll want to do is check the permissions and then ask yourself, what user am I with our who am I command, right? To see what user we are. And usually there's some type of permission conflict that we have to resolve to get access. So we just talked a lot about users. What if we want to switch users on a system? Most normal users won't want to do this, right? If you're just, a person logging into a computer that has a bunch of different users on it, most of the time as a regular user, you log in with your username, just like if you were on campus at school, you would log in like a school or a library computer under your username, and that's it. And you're that user, and then you log out and you leave. When we talk about defensive security, so system administration, or when we talk about offensive security, you're hacking into a system. The name of the game is changing users. You might log in as a certain user, and then your goal is to change until you can get to administrator user. Same thing for system administrators. Sometimes if we're helping users troubleshoot, like if you're working on an IT help desk and a user is having issues with something, you might get to a point where you need to log in as that user or change to that user so you can see for yourself what's going on and try to solve the problem for them. On Linux, there is a command to change users, and that is the su command, which I wrote change user, but really it stands for switch user. That's how you can remember su. You're just switching your user. And the syntax is pretty easy. You type in su for switch user, and then the name of the user you want to change to. And when you do this, so right here, I'm saying I want to change to the user named user2. When you do this, you're going to be prompted for a password, and the password is not your password. It is the user you're changing to, it's their password. And so you have to have that password, and then you type it in, and you become that user.
Stop
Um,
it. No.
be aware. Hot
Ugh.
mic, Dr. Brown.
Oh, I'm sorry.
No, you're fine. Just a heads up.
The dog is bugging me.
I have been there so many times. That's why I'm laughing. As soon as I hear that, I'm like, yep, there's a dog involved. Okay. We're gonna skip over this one just because it gets into a lot of detail. It's important to know this is just an image of the Linux file system. It looks different than the Windows file system, which I think for most people starts at the C directory. So if you open kind of your file explorer, you're going to see a C colon backslash. On Linux, the version of that is this forward slash, and we call that the root directory. And you can see it's kind of like a tree here, like you can think about like a family tree. Everything underneath are kind of nested directories, and all of these directories hold different files by default. So there's a different purpose for each of them. I kind of listed the important ones to know as a beginner and for cybersecurity kind of competitions here. They're all important in their own way, but there's a lot of them, as you can see. The kind of the key ones that you'll probably interact with the most are the etc directory under root. So if you're following my mouse, it's this one right here. This one contains normally all the configuration files for programs installed on a system. There is a VAR or a VAR directory, and this holds variable data. One key piece of data that the VAR directory holds are all of your log files or the records for the system. So these can include the records of who's logged in and who's logged out, the different application logs. Like if I'm running a web server, this folder will hold within it the logs of all of the different IP addresses that have accessed my website, and then what they've done on my website. What pages have they gone to? What files have they downloaded? What files have they uploaded? All of your log files will be in this VAR folder most of the time. So that's a good one to be aware of for cybersecurity. There's a TMP folder used for temporary files. This one is good for both red team and blue team. Red team will tend to put malware in this folder because usually the permissions on the temp folder are such that anyone can read and write from it. So not always, but they might drop kind of different staging files or reverse shells or malware stuff in this folder. And then blue teams want to kind of keep an eye on this folder and monitor it. Again, really good red teamers are ones who are professional, probably won't use this folder because it's so common. They have other folders that they use, but this is a common one. I think you'll see a lot in cybersecurity competitions. You'll want to check that folder for any kind of weird name files that aren't there by default. And then you have the /root folder. This is the home directory for the administrator user. So just notice in the picture, I'll zoom way in, we have this / at the top, and that's called root. That is the root of the file system. Underneath that, we have another folder that it's actually not in this picture, unfortunately. It's an oversight there, but there is another folder called /root, just like this. That is a different folder. They're called the same thing, so there's a lot of confusion most of the time. But /root is the home directory for the root user. So just keep that in mind. If you hear go to the root directory, sometimes you got to specify what do you mean, the root users directory or like the / directory. And as you get more familiar and more experienced, you'll learn to call them slightly different things so you're clear. Okay, so we talked a lot about that. Let's jump into our challenge. So I'm going to pop out this documentation so that I can follow along. And then I am going to pop out, well, I'll keep this here. Let me make my font bigger so you guys can follow along. Uh, I'm going to make my font as big as I can for you all. There we go. I'm going to do one more even. Okay. Hopefully this is big enough. I'll try to make it a little bigger. Okay. That's pretty big there. So you don't have to do that part. I know it's hard to see on screen share sometimes, and so I wanted to make this a little bit bigger. And then I am going to full screen this, so hopefully it's even bigger. And I'm not going to share the documentation just so you can get full screen real estate. Just know I'm following along with our documentation on another screen. And I am starting on page, if you want to follow along too, I am on page 21 of the PDF file, the interactive documentation here. So the first thing page 21 tells us for our interactive challenge is it says, hey, we want to start off first by issuing the command SSH user1 at 192.168.220.20. And so right now, we haven't gone over this command yet, but if I want to get the IP address of my current computer system I'm on, this one that I'm looking at right now, the only one you have direct access to in NetLabs, I can type in the command IP space A, and I will kind of see here an IP address. If you're looking kind of at my mouse, if that shows up, my current IP address is 192.168.220.10. And so what we're being told here is that there's another computer system that's not this one that's located at the IP address 192.168.220.20. And we want to, using SSH, log into that other system. And again, we can't access it through NetLabs. I've only given you one system here, Linux Training 1. There is another computer, though. You just have to use SSH to get to it. So I'm just going to type in the command that I see on page 21, SSH space user1 at, and then the IP address. Think about this as like an email kind of, right? So before I hit enter, if I was writing an email to someone, it might be like their name at gmail.com. And gmail.com is really just the DNS name for an IP address. And so SSH has a very similar syntax. When you use SSH, you SSH to a username at the IP address of the computer system. That's the syntax. Username that you want to log in as, at, like an email, and then the IP address. So that's always how we use SSH to log into another computer. So again, the username that we're given is user1 at, and then the machine name or the IP address is 192.168.220.20. And then we're prompted for user1's password. We're told on page 21 that the password is also user1. Not very secure, but easy to remember. So same as the username. I'm just going to type in user1. I typed it in, and if you're following along, it might look like nothing is showing up in your terminal when you're typing. Your cursor didn't move and it's just blank. Trust me, you're actually typing something in. This is this old security kind of mechanism built into Linux. Oftentimes, when you're prompted for a password or sensitive information, you won't see like the little stars that you might see if you're using a website or Windows. It'll look like you're not typing anything. You are, in fact, typing something. It's just so that someone looking over your shoulder can't get additional information like how long is your password? How many characters is it? So just trust that you typed it correctly and hit enter. And then you should see that you get a prompt back, and the name of the computer now, if I type in, who am I? First of all, I'm user1. And then if I look at my prompt, or I type in host name for the name of my computer, I'm now Linux Training 2. So this is a separate, we used to be on Linux Training 1, now we're on Linux Training 2 here. Okay, so we got into our new computer through SSH. And now we're going to answer some challenges here. The first one says explore the manual pages for the ls command, and the question is which flag makes ls list one file or directory per line? I'll leave this challenge up to you all, but I have the ls man pages here. And so really, you can just search through this for like one file, and you'll find your answer pretty quick there. But I'll leave that up to you to answer that challenge. It's just about making sure you know how to use the man command. Okay, the next one, number 3, says create a new file named my_file. So it's not telling us what type of file, it's just saying make a file. There was a command that we learned to do that we just talked about briefly. And if anyone remembers, you can toss it in chat. Starts with a T, touch, yeah. So when we want to make an empty file, we type in touch and then the name of the file. So I'll just put in my_file. If I do ls now, there's my file, right? Example file was already there, but here's my new file, my file. All right, and then it asks what type of file is example file. So remember, when we're looking at a file in Linux, it doesn't always have a file extension. And just by looking at this ls output, I can't tell, what is this? Is this a video file, an image? I don't know. But there's a command called file, and we can type in file and then the name of a file, and it will give us more information. So this says ASCII text. And really all this is a text file. ASCII or ASCII is a type of encoding that is common with text files. On Windows, or a more modern version of ASCII is called UTF-8. Almost all text files that you'll see are going to be UTF-8, unless they're proprietary, like DocX or Microsoft Word files, something like that. And so this is a text file here. So if we're curious, we can cat it since we know it's a text file. And we see that all it says is this is an example ASCII text file, right? Nothing special there, but we can see what type of file it is. Now, what do you think about my file? That file we just made. What kind of file do you think that is? Any guess is good because we haven't gone over this. Well, let's check. It's what's known as an empty file. Exactly. Yeah, there's nothing in it yet. So it doesn't have any bytes at all. It's just totally empty. It's kind of think about it like an empty vessel ready for data to be placed into it. But at this point, it could be anything. We can turn it into a text file, an image file, a video file, whatever we want. But right now, this is the file type known as empty, basically, or nothing. All right. Next challenge, challenge 5, says create a directory named my directory and then move my file into my directory. Okay, so there's a couple steps in this one. Let me do an ls again. Right now, I don't see any directories. I just see 2 files, our ASCII example file and our empty my file. Step number 1 is, remember, just to demonstrate this, I'm going to try to move my file to my directory before making it, and we'll see what happens. So move my file to my directory. If I hit enter and then ls, well, my file is gone and I see my directory. If I do an ls-a, or sorry, an ls-l, my directory is not actually a directory. If I try to cd into it, I'm going to get an error, my directory, not a directory. So what we've done here is kind of the classic mistake that is easy to make with move. We renamed it because we tried to move this to a directory that didn't exist yet. So I'm going to move it back. I'm basically going to rename it back to what it was. Okay, ls, now we're back to where we started. So if I want to move it to a directory, first I have to use the make dir command, mkdir, and I'm going to call this my directory. I'll do an ls in between just to check my work and see that I'm doing it right. There we go. So now I have the blue colored my directory. If I do an ls-l, you see how my directory starts with a D? That indicates that it's a directory. Files will just have a dash, but if it's a directory, it'll have a D. In case the colors aren't showing up for you or something, you can also verify with ls there. And then now that the directory exists, we just have to do some moving. So now we can run our same move command that I ran. Where is it? There we go. And this time it'll actually move the file if the directory exists. So I'll do ls. My file is gone, but my directory is there. If I cd into my directory and then run ls, there's my file. Okay, so that's kind of the 2 examples of how to move a file and rename a file. Okay, next question. We went over this briefly, so I'm in challenge 2 on page 23. And the question is, which directory contains log files? So I talked about this briefly. Does anyone remember when I went through it kind of briefly? It's also in the slides if you scroll up a little bit. Remember the name of the directory that has the log files? Yeah, /var is the name of the directory. And specifically, let's go to that directory. So I'm going to cd to /var, right? PWD shows me I'm in the right place. If I ls, there's another directory called log, and that's actually where most of the log files are. So I'm going to cd again to log. Now if I do pwd, I am in var log /var/log. Now I'll do ls. Okay, now we have some log files here, some various log files. So we're in there. It says navigate to the log directory and find the file important. I see it right here, right? It's right in, for me, it's in my middle column under fail log. Depending on the size of your terminal, it might look like it's in a different place, but you should see one called important. And we're asked, who is the owner of this file? So remember, we can use our ls command to look at permissions and ownership. So I'll do ls-l. We got to use the -l to see permissions, and then the name, which is important. And so right now, I see that the user that owns this file is 640, and the group that owns it is user2. That might be an error in this VM right now, but the answer should be user2. That is the group that owns it. Let me check my important. Don't worry about this part. I don't know how that ended up at 640. So this VM was behind the scenes transferred from VMware to Proxmox. We might have had an issue that popped up. We should still be able to solve this challenge. Just know this is my error where the user for this file and the group should be user2 for both. So 640 is in the user field, user2 is in the group field. Remember, who are we? Who am I? I'm user1. So it says to try to read the contents of important, what happens. So first I'll do a file on it just to see what are we dealing with, what is important. It's a regular file, but I have no read permission. So it actually won't even give me the information that I need to read it. And if I try to cat important, I get permission denied. And again, the reason is if we look up at our permissions, remember the first set of three are the name of the user, what permissions they have. So user2 can read and write to this file. The next set of three are the group. The group is also user2. They can read. What we care about is the other or the last three permissions because we're neither 640 or user2, right? We're other, and we have no permissions. They're all dashes. So we can't do anything with this file at all. We can't move it, we can't read it, we can't execute it, nothing. So in order to do anything with this file, we have to switch to user2. So we're in that user2 group or we're the user2 user in order to do anything. So how do we switch to user2? Does anyone remember the command to switch users here? Because user1, remember, we are, who am I? User1, we can't do anything. Yeah, so Claudia, perfect. Yeah, Claudia and Nathan, you're both right. So we want to use the su command, switch user, followed by the user we're switching to. So user2. And we're asked for a password. If we look at the challenge, I'm on number 5, we're given the password. And just like user1, the password for user2 is the username. So the password is user2, no spaces. Okay, I got my terminal back. Let me confirm, who am I? Oh, I'm user2 now. Okay, now let me try again to run file on important. Okay, now I get something different. EBUSTL subtitles. Let me cat important, and I get a flag here, coastline user2 underscore SU. Okay, so that's like an easy level challenge you might see in an NCL or another CTF where you are given a file and you're said, read the contents of this file or the flag is in this file and you don't have the right permissions. And you probably won't be given the password for the user that does have the permissions, but you'll be given another avenue to become that user or to get their permissions. And then your whole goal is how do I switch to this user? In what way can I gain access basically to this file I'm not supposed to have access to? All right, but that's just demonstrating permissions for everyone there. Okay, the next section is some text editor stuff, which is important. Trying to figure out how much I want to spend with you guys going like reading this to you versus this stuff I'm confident you can just read and practice on your own. Yeah, why don't we do Yeah, I actually want to go down to page 27 and talk a little bit about transferring files between these two systems. So far we've used SSH to log in from one computer to another, which is great. What happens if we want to transfer files back and forth between these two computer systems? Using SSH, we can do that. And there's actually another command line tool called SCP, which it's short for secure copy, and it's done over SSH. But essentially, it uses the SSH protocol, that's secure encrypted protocol, in order to transfer files or folders from one computer to another. And the syntax is important and it's under the examples. Let me switch my screen share back to contents to show where I'm at. Okay. So the syntax, the format for running this command is it's SCP. You start with the source file, so the file that you're going to move, and then you end with the destination or kind of where you're moving it to. And so here is two examples. One is from local to remote. And what this means is this is how I transfer a file from the system I'm currently on to another system at a different IP address. And we're going to use a file called important.txt for this first example. So I'm on a system, right? Let's go back to my Linux system here. And remember, we have this important file here. So if I want to transfer this file to another system, I start by typing SCP, the file name important, and then I start with, this is the source. So it's just important, and then I put in the destination. Now the destination always has to be in the same format as our SSH command, meaning we start with a username at an IP address, and then we have this colon character because we have to specify, once we specify the user and the IP address, this is just to authenticate. We have to specify the actual path that the file goes to. And so we do a colon, and then everything after the colon is the full file path of where we want to move the file. So in this case, we are transferring a file called important.txt to a user named Ubuntu at a system at this IP address. And then specifically, we're putting that file in /home Ubuntu, and we're renaming it transfer.txt. So important.txt is going to get moved to this directory on this IP address, and it's actually going to be renamed when it gets there to transfer.txt. That's sending from your local system to a remote system. You can also, or like pushing the file out, you can also get or pull the file in from a remote system to your local system, and we just kind of reverse the order here. So SCP, we start with the same command. Instead of naming the file, we actually start with the whole login thing, right? Ubuntu at 192.168, then the colon, and then the name of the file. And then our last part, our destination, is on our local system where we want it to be. So in this case, we're grabbing a file called document.txt on another computer, and we're putting it this // this is just a shorthand for the current directory that you're running the command from. So in the current directory, I want to download this documents.txt file, and let's rename it notes.txt when we download it. That's what that command is doing right there. So again, this one is uploading, this first version. We are uploading important.txt to this machine. This one is downloading. We are downloading this documents.txt file, and then we're renaming it after it's downloaded. It's another way to think about it. Okay, so SCP we'll use all the time in cybersecurity competitions, both offensive and defensive. How does SCP verify the user has access on the remote host? Good question. Yeah, really good question. So let's look at this first SCP command where we're typing in a username Ubuntu and then this IP address. When we hit enter on this command, just like with SSH, we're going to be prompted for a password for the Ubuntu user. And then we're going to put in that password. And then another thing is going to happen behind the scenes. Once we've authenticated as this Ubuntu user, the Linux system on this other end is going to check the permissions of this folder. And if the Ubuntu user does not have permissions to write anything to this folder, we're going to get an error back, and it's going to say permission denied error. So really good question there. So yeah, the credentials that are being checked or the permissions are always the user that you are kind of authenticating as. Same thing for this download version. So when we run SCP Ubuntu at this IP address and we put in the password, the Linux system on the other end at the .30 is going to check the permissions on document.txt. And if the Ubuntu user does not have permissions to read that file, we're going to get a permission denied error. Hey, you can't download this file. Ubuntu is not allowed to read it. Yeah, so good question there. Okay. The last thing we'll touch on today is another way to transfer files, and this is to serve them using Python on the system here. So the reason that we use Python to do this is it's a really short command to start up essentially a web server that can serve files that can be downloaded from any other computer system. And it's with the syntax python 3-m http.server. And what that will do is from the directory where you run this command, it will host every file and folder in that directory available basically at the IP address of the system that you're running it on by default on port 8000. And so from there, you can navigate and download files. You can only download, you can't upload using this method. But you can download any files. And so this is a common technique used by red teams or something like that. If they want to get a file from their local system to another system, and they have access to like a web browser or a tool like curl or wget, they might just host this Python 3 server from their attack system, hosting the files they want to transfer. Like maybe they want to transfer over malware or something like that. They would start up this, and then on the other system that they might have access to, but they might not know the password. That's actually a common scenario where an attacker gets access to a system, but they still don't know the user's password because they got access another way other than logging in. And remember, if you don't have a password, you cannot use SCP to transfer files. You need a password in order to do this. And so if you're in a scenario where you're on someone else's computer and you don't have their password, but you want to download files from your own computer, you can't use SCP, but you can do this on your attack system. And then from the system you have access to, your target, you can download files without having to authenticate from your system using this Python method here. Okay, and then after this, it goes more into some more intermediate stuff, I would say. This is looking at basically the version of Task Manager on Linux here, where you're going to look at some process and process IDs. This is looking at all the running programs on your system. Commonly, this is a first line of defense that you'll have to use in a competition like SoCal Cyber Cup to identify if red team is on your system. Is there a hacker logged into my system? Are they running programs in the background that I don't know about that shouldn't be running? Tools like PS or HTOP, which is the image to the right, will show you, it's just like Windows Task Manager if you use that. It'll show you all the running stuff on your system and who's running it. There's a user field. And so this is a place you kind of want to constantly monitor if you're suspicious, looking for activity of red team. And you'll also learn how to stop processes or terminate or kill those tasks. Then we go into some more automation stuff. Yeah, so I think we can continue on with this next time. Again, I'd recommend if you all have time, follow along. The slides here are pretty good in that they'll highlight everything you need for the challenges. And then the challenges are very step-by-step. They'll give you specific instructions of kind of how to find the flags in the environment. And so you can continue on. What I really recommend, though, especially for those of you competing in NCL or SoCal Cyber Cup who are interested in that, definitely go back and go through on your own in NetLabs what we covered today, because these are foundational commands, and I promise you, you will use these every single time you do a CTF. Every one of these commands you're going to use over and over and over and over again. So it's really good practice to get familiar with them now, get comfortable with them, understand what these tools do and why we use them. And then as we move more into our specific CTF training, you're going to see, oh man, I'm really glad that I learned how to use these commands, because most of the CTFs are all Linux, right? Very, very few of them have Windows stuff. When we're talking about NCL, it's almost exclusively Linux you're going to be working on. So we're going to spend a lot of time kind of really honing down and getting good at our Linux skills. Okay, so let me pause right here. I want to pause for any questions if anyone has any. Otherwise, Dr. Brown is going to pick up and kind of move into some SoCal Cyber Cup training, I believe, here. And so everyone is welcome to stick around for that. I'm putting you on the spot. I didn't know if you were having that for sure today or not, Dr. Brown, but if not, we'll pause for questions and then we can also wrap up here.